Hello everyone. So this is experiment number 6 of the digital lab experiments, that is flip-flops. Here we have included the SR flip-flop, JK flip-flop, D flip-flop and the T flip-flop. First let us take a look into the SR flip-flop. First of all, let's take a look at why the term is named as flip-flop. So this relates actually to the operation of the device, because the logic set state can be flipped or it can be flopped back to the opposing logic reset state. So that's why this device is called the flip-flop. And now let's look into the SR flip-flop. So in an SR flip-flop, the circuit is used to store the single bit data in memory circuit. So it has a total of 3 inputs, in which S and R are 2 of the inputs, and the Q is the output. So this output is actually related to the current history or the state of the device. So in the set state, the input R is set to false or 0, and the input S is set to true or 1, and NAND gate Y has an input 0. So as a result of this, it will produce the output Q dash as 1, and in the reset state, the value of R is equal to 1 and S is equal to 0, and one of the inputs of the NAND gate X is 0 and its output Q is subsequently 1. So here we have the characteristic table, in which we have the clock pulses, the input S and R, and the present state Q, and we also have the next state, which would be Q plus 1. Now let's take a look at the simulation for the SR flip-flop. So here we have the simulation for the SR flip-flop, which includes two switches, a clock pulse, and obviously the SR flip-flop, and the two outputs Q and Q dash. We have two bulbs indicating the state of the output. So that's the simulation for the SR flip-flop. Now let's move on to the next flip-flop. So the next flip-flop is the JK flip-flop. This is basically a gated SR flip-flop, and which has an addition of a clock input that prevents the invalid output condition that can occur when both the value of S and R are equal to the logic level 1. So because of the addition of this clocked input, a JK flip-flop has 4 possible input combinations, which are the logic 1, logic 0, no change and toggle. These are the 4 possible input combinations in a JK flip-flop. So here we have the truth table, which obviously has the clock pulses, and also, as we told, we also have the toggle action in the truth table. We have the inputs J and K, which in our case, and we have the outputs Q and Q dash. Now let us take a look at the simulation of the JK flip-flop. So as we could see, here we have two switches, a clock pulse, and we also have 2 bulbs to indicate the state of the output, and we also have a NOT gate connected to another clock pulse. So that's the simulation for the JK flip-flop. Now let's move on to the next flip-flop. So next we have the D flip-flop. So basically the D flip-flop are constructed from a gated SR flip-flop. The only change is that an inverter is added between the S and R inputs to allow a single D, that is the data input. Now this data input is labeled as D, and it is used in the place of the set signal, and the inverter is used to generate a complementary reset input. Thereby we have a level sensitive D type flip-flop from a level sensitive SR latch, and the only difference is here S is equal to D and R is not D, as shown. So here as long as the clock input is high, it will store the output regardless of the logic level, and once the clock input goes low, the set and reset input of the flip-flops are both held at the logic level 1. So here we have the truth table for the D flip-flop. Now let us take a look at the simulation for the D flip-flop. So here we have the simulation for the D flip-flop, which includes 2 switches, a clock pulse, a NOT gate, and also an AND gate, and we have 2 bulbs indicating the state of the outputs. So that's a simulation for the D flip-flop. Now let's move on to the final flip-flop. So the final flip-flop is the T flip-flop. So T flip-flop is basically the simplified version of what we saw, that is the JK flip-flop. So it is simply obtained by connecting the same input T to both the inputs of the JK flip-flop. So as a result of which it operates with only positive clock transitions or negative clock transitions. Here the inputs of the JK flip-flop are considered as J equal to T and K equal to T. That's as told earlier, the same input we consider T for both the inputs of the JK flip-flop. That's why J equals T and K also equals T. So in order to utilize this modified JK flip-flop for two combinations of inputs, so here the outputs Q of T and Q of T plus 1 are present state and next state respectively, and so the T flip-flop can be used for one of these two functions, such as hold and complement of present state when positive transition of clock signal is applied. So here we have the characteristic table which includes the inputs as I told earlier, which is the T for both the J and K, and we also have the present state and the next state, which is Q of T and Q of T plus 1. Now let's take a look at the simulation for the T flip-flop. So as we could see, the simulation for the T flip-flop includes two switches, clock pulse, we have an AND gate, a NOT gate, and we also have two switches in order to indicate the state of the output. So that's the simulation for the T flip-flop. Thank you.